So in this video, we're continuing our discussion of eccentricity. So from the last slide, we said the max moment occurs at E times secant of K L over 2. All right, so we're going to plug in K for K, this P square root of P over e to the IZ term. So if you remember, I or r of g, or the radius of gyration, is equal to the square root of iz over a. So we can say that iz is equal to a times rg squared. So if we plug that in to this equation here, you get this value here, right? So if we do that, what we'll get is our maximum moment will be equal to this equation here. And then to determine our maximum stress, we can say that that will be equal to our compressive stress plus our bending stress. So our force over the area plus our MC over I term. So if we combine those two values, what we end up getting is we get this equation here for our maximum stress. Right? So this is valid when the eccentricity is greater than 0. And then basically determine how eccentric something is, we use this eccentricity ratio term, which is just equal to E times C over RG squared. All right. So, so to use the secant formula, what we can do is we need to first determine this eccentricity ratio, Young's modulus of the material, the yield strength of the material, and also we need to know the slenderness ratio, L over Rg. So we need things like I and A to get that as well. And we need to solve for P over A iteratively. So what you basically would do is you would guess and check using Excel. So you would start with a given L over Rg, something like L over Rg is equal to, I don't know, 50, for example, right? And then you would say in column 1, you would list a number of different stresses. So you would say P over A. So maybe you would say something like, I don't know, 5, 6, 7, all the way to a certain amount of kpsi, right? And let's say 100 kpsi, and then you would calculate the sigma max stress for that given P over A. What you would get is you would again get, I don't know, you get various values of stress corresponding to each P over A. And then at a certain point, your sigma max would be greater than or equal to your sigma yield, and that would be your critical force or your critical P over A, right? And then you could use this method to calculate a diagram such as this on the top, where we have various slenderness ratios for different, various eccentricity ratios and various slenderness ratios. And you could calculate these different curves here, right? So what you'll notice is that as EC over RG squared increases, our P over A decreases. All right, so our maximum stress or allowable stress decreases, right, with increasing slenderness rate.